Okay, good. So the first question is from University Entrance Exam 2017. Which one of the following experiment errors can be reduced by taking repeated measurements? A, parallax error, B, systematic error, C, random error, D, zero error.
C, random.
Yeah, so types of errors, and basically there are two types of errors. The first one is systematic error, and the second one is random error. Systematic error means this is the error due to out of calibrations of the instrument, and random error is the error due to the person, which is made by the person. So maybe the random error is reduced by taking repeated measurements because this is coming from the person's side. Therefore, we can reduce the random error by taking the repeated measurements. Excellent. So option C is the correct answer. Question number 2. A teacher gave a student a book whose thickness is 4.3 centimeter and instructed him to measure the thickness of the book with Bernal calipers. The student took 4 measurements. The average and the standard deviations of the measurements were 4.33 centimeter and 0.043 centimeter respectively. Which one of the following is the uncertainty in a student's measurement? A, 0.03 centimeter, B, 0.04 centimeter, C, 0.035 centimeter, D, 0.3 centimeter.
0.04.
Why 0.04?
What is the deviation, the standard deviation from the average?
The average and the standard deviation of the measurements were. So you said that the standard deviation is the uncertainty?
Yes.
Okay, 0.04. What about the average value is given? The teachers give the students book with thickness 4.3 and the students measure 4.33. I think 0.04 is the student's average deviation, yes?
Yes.
So can we say that that is uncertainty? Because the value is given by the teacher, which is 4.3 centimeter. Is that deviation from the exact value given by the teacher or the student's point of view?
Deviation from the student.
Can we say that is uncertainty? Because the uncertainty for when you measure the measurements of some thing, for example, let's say here the thickness, you have to put the value, the measured value plus or minus the uncertainty, yes?
Yes.
Okay. So this 0.04 is the uncertainty, you said. Why not? Because the teacher gives 4.3 centimeter. 4.33 is the student's measurement value. Can we say that difference is uncertainty?
Here, the difference from the
exact value, which is given by the teacher?
Yes.
So why not 0.03 centimeter?
Yes, it is.
So which one is the correct answer?
0.03.
Yeah, 0.03 is the correct answer. Option A. Okay, let's see question number 3, which is from 2008 Ethiopian Calendar University Entrance Exam. Which statement is wrong about units and dimensions? A, two quantities can have the same units but different dimension. B, two quantities can have the same dimensions but different units. C, it is always possible to add two numbers that have the same units. D, there are quantities that have no units and dimensions. Wrong about units and dimension.
C.
C, it is always possible to add two numbers that have the same units is wrong. Why? Give me an example for this.
Newton meter.
Newton meter for work and torque.
Yes.
Again, you can say speed and velocity, yes?
Speed, yes.
So option C is wrong about units and dimension. Excellent. Let's see question number 4. If a precision of surveyor measured a distance of 500 meters between 2 points in a village using a meter that has centimeter division on it, then what is the measurement result? A 500 meter, B 500.0 meter, C 500.00 centimeter, D 500.000 meter. It is centimeter division, yes?
Yes.
No, option C is not centimeter, meter, sorry.
Yes, C.
Yeah, therefore 100 had 1/1000 division, which is when we express centimeter into meter, we put into 0.010002, yes? Therefore, option C is the correct answer. Excellent. This unit is not centimeter, it is meter. It is editing problem.
No.
Okay. Let's see question number 5. Which one of the following statement is correct about errors in measurement? Errors in measurement. Experimental error is the same as mistake. A. B. Errors occurs in every scientific investigation. C. Errors make measurements value the same as the accepted value. D. Errors can be avoided by using modern measuring instrument. Correct about errors in measurement.
B.
Yeah, excellent. The correct answer is errors occur in every scientific investigation. Error is not a mistake. Option A cannot be the answer because experimental error is not a mistake. Option C is errors make measurements value the same as accepted value. No. Errors can be avoided by using modern measuring instrument. No. So we can minimize the systematic error by measuring using modern measurement instrument. So, but we cannot avoid the error. So option B is the correct answer. Excellent. Let's see question number 6. What can be concluded when the number of significant figures increase? A, true reading increases. B, uncertainty increases. C, precision increases. D, accuracy increases.
D.
Accuracy. Accuracy increases. The number of significant figures increases. What about precision?
Precision is how much a value is near to the others.
Yeah. So the number of significant figures increase. can we say that it is more precise or accurate? I mean,
Precise?
if it is precise, we cannot say accurate, yes?
Yes.
But
Not
if
always.
it is accurate, maybe we can say precise. So does the number of significant figure tell us accuracy or precision? For example,
Precision?
maybe if the number of significant figure increases, we can say, for example, 2.001, 002, 003. Maybe the exact or the accurate value will be 2. If that makes sense, we can say accuracy increase.
No.
So I think, I mean, I have a doubt also from another students with these questions. And in the extreme book series, the answer says accuracy increases, but I don't agree by that one. Because if the reading is precise, we cannot say accurate, yes?
Yes. Not
Maybe the
always.
significant figure, if the significant figure increases, we can say precise, but we cannot say accurate. I mean, I don't agree. I said precision increases. Did you agree by my idea?
Yes.
So let's make the answer option C.
No.
Okay. Let's see question number 7. A grade 11 physics teacher ordered 4 of his students to measure the length of classroom. He provided them the following length measurement instruments. The instruments are meter rule with millimeter division, Bernard calipers, micrometer screw gauge, and meter tap with centimeter scale. But its zero reading is not visible. Which of the following instruments is appropriate for the task to measure the length of the classroom? A, meter rule, B, Bernard caliper, C, meter tab, C, micrometer screw gauge.
Meter tape?
Meter tape. Because screw gauge measuring the classroom length using screw gauge is difficult, okay? Because screw gauge is an instrument used to measure the diameter or the thickness of a solid object, yes?
Yes.
Again, the Bernard caliper has the same function with micrometer screw gauge. Therefore, the correct answer is meter tape. Okay. Let's see question number 8. Which part of scientific report discuss the accuracy of measurements taken? A, aim, B, theory, C, methods, D, results.
D?
D, result.
Yes.
Which part of scientific report discuss the accuracy of measurements taken? Can we say in the result we discuss the accuracy of the measurement? What about
the method? The method, yes.
Yeah, the method is the correct answer, yes, because in the method we do these experiments based on this there is an accuracy in this measurement, blah, blah, yes?
Yes.
So option C is the correct answer. Okay, we can submit our result. We can view our score. So we did 8 out of 8. You can clap for yourself. Is there any question up to this?
No.
On measurements and practical work. This is all about grade 11 chapter 1, which is about the measurement and practical work. You can see there what is significant figure, What is percentage uncertainty? Percentage uncertainty is given by the uncertainty divided by the measured value times 100%. How can we measure the uncertainty? For example, given the measurement X with uncertainty delta X, measurement Y with uncertainty delta Y. So what is uncertainty when this uncertainty is given in percentage? What is the uncertainty when we get some quantities by multiplying or dividing or subtracting or adding the quantity X and Y? Did you remember? For example,
Yes.
Given the uncertainty in measuring the mass of the body or the object is 1%, the uncertainty in velocity is 1%. What is the uncertainty in kinetic energy?
Kinetic energy?
Uncertainty in mass is 1%. Uncertainty in velocity is 2%. What is uncertainty in kinetic energy? Kinetic energy of the object is given by half mv square, yes?
Yes.
So what is uncertainty in kinetic energy?
1%. 0.1 or 2. Square. 0.5.
Is that?
Or is
So given the measurement X with uncertainty delta X and the measurement Y with uncertainty delta Y, let's say delta Y, So what is uncertainty in X plus Y? The uncertainty should be in percentage. So what is uncertainty in X plus or minus Y? The uncertainty in X plus or minus Y, uncertainty ሁል ጊዜ ምንድን ነው የምናደርገው? ድምር ነው የምናደርገው ማለት ነው። Okay?
Multiply
delta X times, plus delta Y is the uncertainty in X plus or minus Y. ስለዚህ ኳንቲቲውን X plus or minus Y ብለን ከሆነ የምናገኘው uncertainty-ውን ስንፈልግ ሁል ጊዜ ድምር ነው የምናደርገው ማለት ነው። But the uncertainty must be given in percentage መሰጠት አለበት ማለት ነው። What about the uncertainty in X plus, for example, if X times Y, the uncertainty in X times Y is again given by delta X plus delta Y. Again, for the division, for example, the product, for example, we can calculate the force mass times acceleration is, if the uncertainty in mass is, for example, 1%, and if the uncertainty in acceleration is 2%, what is the uncertainty in force? ምን ይሆናል? 3% ይሆናል ማለት ነው። Is it clear?
Yes.
Again, if we get the quantity, for example, by dividing X divided by Y, X divided by Y, x divided by y given by the uncertainty in x over y. For example, we can measure the volume and the mass. The density is given by mass over volume. So what is the uncertainty in density given the uncertainty in mass and volume? So always you have to add the uncertainty, which is delta x plus delta y ብለን ነው የምናገኘው ማለት ነው። Don't forget this, okay? Uncertainty ሁልጊዜ ሁለት ኳንቲ ሜጀር አድርገን with uncertainty delta x and delta y. The uncertainty in x plus or minus y, or the uncertainty in x times y, or the uncertainty in x over y is always delta x plus delta y ብለን ነው የምናስቀምጠው ማለት ነው። Keep in your mind this, okay?
Okay.
Good. But don't forget that the uncertainty must be put in percentage. For example, if given the uncertainty x 2 plus or minus, for example, 0.3, to change the uncertainty in percentage, you have to divide 0.3 by 2 times 100%. That is the uncertainty percentage, okay?
Yes.
You have to do in that form. So, for example, in measuring the volume of the sphere, what the uncertainty in radius is 1%. What is the uncertainty in volume measuring of a sphere?
The equation for volume was 1 over t pi r square.
The volume of a sphere?
Yes.
Is what?
1 over 3.
Is that? A sphere.
Yes, 1 over 3 pi r square.
1 over 3 pi r square, volume of a sphere. 4 over 3 pi?
4 over 3 pi r cube.
Yes, 4 over 3 pi r cubed is the volume of the sphere. So, in measuring the radius of the sphere, the uncertainty in radius is 1%. So, what is the uncertainty in volume?
1%.
So, r cubed means
1 cube.
r times r times r, yes?
Yes.
So we have to add 1% 3 times. Therefore, the uncertainty should be 1% plus 1% plus 1%. Therefore, the uncertainty in volume is how much? 3%. So tell me the answer for the previous question.
3.
So
the kinetic
the uncertainty in measuring the kinetic energy of the body, the uncertainty in mass was how much?
1%.
The uncertainty in velocity? 2%, yes?
Square? Yes, 2.
So forget about the formula. You have to forget about half. Therefore, the uncertainty should be m times b times p. The uncertainty in mass is 1% plus the uncertainty in velocity is 2% plus, again, because it is b squared, the uncertainty in b 2%. Therefore, what is the uncertainty in kinetic energy? 5%, okay? Try to keep this in your mind. Again, let's ask you another question. In measuring the voltage of the circuit, the uncertainty in voltage is 2%, and the uncertainty in current is 1%, what is the uncertainty in measuring the resistance of that circuit?
Velocity voltage is 2% and current is 1.
Yes.
It will be 3.
3. So
Yes.
the uncertainty when we divide or multiply, it is always the uncertainty in x plus the uncertainty in y. If there is a cubed or a square, you have to write, for example, 4r cubed r times r times r. Therefore, the uncertainty in r, you have to add together the uncertainty error for that measured value. Okay? Is it clear?
Yes.
Good. What about your knowledge about significant figures? For example,
Yes,
let's give you an example. Let's erase this. Can you see the shared screen?
Yes.
Okay, good. So, for example, given the number 0.501, 0.500, 0.00678, blah, 1.2, 20056. What is the uncertainty in option 1?
Uncertainty?
Sorry, the number of significant figures.
3.
Sorry, what about 2? Option 2?
1.
Is that
3.
3? What about option 3?
3.
3. There is no significant for this case. For this case, 0 is significant. Don't forget this part, okay?
Okay.
So what is uncertain, the number of significant figure for this?
6.
1, 2, 3, 4, 5, 6. Okay, good. What about this? 500?
One.
Okay, maybe 1, maybe 2, maybe 3. If you write just like this is ambiguous, okay? Because you can write this 5.00 times, for example, 10 to the power of 2. In that case, you will have one significant figure. If you write 50 point something, so if you write the number except 0 plus 0, for that case, the number of significant figure is ambiguous. What about if this is measured value, for example, 500 meters?
It will be 3.
3. For the measured value, in this case, the 0 is significant, therefore 500 meter has 3 significant figure. Okay, let's write in exponential form, for example, 0.012, okay, times, for example, 10 to the power of 3. What is the number of significant figure for this?
4.
4. So, what you have to keep in your mind, don't forget these types of editing for the significant figure. At this case, 0 is significant. And if you write 500 only, this is ambiguous. You can say 1, 2, 3. But when it is measured value, this 500, the 0 now is significant. Clear?
Yes.
So there is types of error, systematic error, random error, types of examples of systematic error, for example, zero error, examples of random error, parallax error. You have to revise that part. then accuracy, precision, what is accuracy, what is precision, can we say something is precise, it is accurate? So you have to revise that part by yourself. So let's go for the vector physical quantities. Up to now, if you have any question, let me know.
Okay.
It is fine.
Yes.
Good. Let's go for vector physical quantities part.